Hi guys, welcome once again to Endeavor classes. So in this lecture, we'll continue further with the chapter Electrostatics. As we have already discussed, electrostatics is that branch of physics which deals with the study of every aspect of a charged particle at rest only. That means it deals with all the physical phenomenon or physical properties associated with a charge when it is at rest only. But the origin of electrostatics, it dates back to the 600 BC, when the Greek observed that when an umber is rubbed with fur, you see umber is nothing but it is the fossilized pine tree resin. That means the pine tree resin, after getting fossilized, it is called as umber. So when the umber is rubbed with fur, it was capable of attracting small pieces of dry leaves or small pieces of straws towards itself. From this, so this was the first evidence of electricity observed by the Greek people, and the type of electricity they observed in the umber when it is rubbed with fur, it was static in nature. So this type of electricity was also called the static electricity. Later, Sir Benjamin Franklin assigned the positive and negative charges to the rubbed bodies. By assigning positive and negative charges to the bodies, he meant that the bodies were behaving in two different ways. That means when the bodies are rubbed, they were behaving in two different ways. That is, one body was behaving in one way and other was behaving in another way. So in order to represent the two behaviors, two different types of behavior of the bodies, Sir Benjamin Franklin assigned positive and negative charges to the bodies. Later, from Thales' experiment, it was concluded that there exist only two kinds of charges in the nature. That means there exist only positive and there is no existence of a third charge. There is only existence of two kinds of charges in nature, that is the positive and negative charge. Later, it is this type of behavior, that is when the umber is rubbed with fur, the static electricity that developed, the same kind of phenomenon is also observed in other substances also. When a glass rod, it is rubbed with silk, and when an ebonite rod is rubbed with wool, they were also capable of attracting small pieces of papers towards themselves. So from this, it was concluded that after rubbing the bodies with each other, they were developing some additional properties by virtue of which they were capable of attracting small pieces of other substances towards themselves. So from this discussion, we can reach at the conclusion of a charge, that means the definition of a charge. So see, the definition of the charge is that it is the property of the body, or it is the property of matter by virtue of which it produces or experiences electric and magnetic forces. So let me explain. You see, when the umber is rubbed with fur, only after rubbing, the umber was capable of attracting small pieces of dry leaves towards itself. but before rubbing it was simply a piece of substance. It was not capable of attracting those pieces of straws. So definitely there must be certain changes occurred in the umber after rubbing it with the fur. So in order to define charge, we have to deal with this definition. This is the appropriate definition of the charge. You see, it is the property of the matter by virtue of which it produces or experiences electric and magnetic forces. So you see, once the charge is developed on the body, then only it can produce electrical forces or it can experience electrical forces. And once it will come into motion, once the charges will come into motion, it will either produce or experience magnetic forces. So long as there is no charge on the body was not capable of attracting certain other substances. But once the charge is developed on the body, it was capable of producing or experiencing electric and magnetic forces. So it is quite clear, the definition is quite clear now. So it is the property of the matter by virtue of which it produces or experiences electric and magnetic forces. Now secondly, we can say that the charge is an intrinsic property of the body. So it is an intrinsic property of the body. By saying intrinsic property, we mean that the charges are already inside the body. That means charges are inherited. They do not depend upon some external factors. The charges, they are already inside the body. That is, they are already inherited. You see, mass, it is already present in the body, but weight, if you go to the physical quantity weight is the product of mass and acceleration due to gravity. So the weight depends upon the factor g. So it depends upon the acceleration due to gravity, but the mass does not depend upon any external factor. So it is already present in the body. It is an inherent or inherited property of the body. Likewise, the charge, it is also an intrinsic property of the body. That means it is already there inside the body. It does not depend upon any external factors. So now moving on to the unit of charge. You see, charge is the derived physical quantity. It is not a fundamental physical quantity like mass. It's a derived physical quantity. It is a derived physical quantity. And it depends upon Q is equal to IT. So it is derived by multiplying the quantity, electric current, and the time. So there are two systems of unit. One is your CGS and one is your SI. The SI unit of charge is coulomb and it is designated as C, and the CGS unit is, again the CGS system of unit can be classified into two subcategories, that is electrostatic unit and electromagnetic unit. Under electrostatic unit, the unit of charge is stat coulomb, and under electromagnetic unit the unit of charge is ab coulomb. Stat coulomb is also called as Franklin. The stat coulomb, or it is the abbreviated form of static coulomb, and ab coulomb, it stands for the absolute coulomb. So these are the two units of charge. And if you go into the dimension of the charge, you see, as charge is the derived physical quantity, the charge is denoted by the symbol Q, as we know. It may be capital Q or small q. So the charge is Q, derived physical quantity, it is the product of current and the time. So Q is equal to IT. As we know, I, the electric current, is a fundamental physical quantity, so it will be, the dimension will be ampere 1 and time 1. If we put the units of this fundamental physical quantity, you will see that it will be Q is equal to IT. So it will be ampere, the SI unit of current is ampere, into the SI unit of time is second. So Q will be, it will be ampere into second, and which is nothing but coulomb. So from this we can say 1 coulomb is equal to 1 ampere into 1 second. So from this we can define 1 coulomb of charge. You see, the charge is said to be 1 coulomb when 1 ampere of current flows through the conductor for 1 second. That means the charge flowing through a conductor is said to be 1 coulomb when 1 ampere of electric current flows through the conductor for 1 second. So these were the units of charge. And the smallest unit of charge, as we discussed, it is the CGS unit, the electrostatic unit is the start coulomb, and it is also called as Franklin. So this is the smallest unit of charge, and the largest practical unit of charge is your Faraday, which is your 96,500 coulomb. You see, 1 coulomb of charge is very large. Later we will see that the 1 coulomb of charge, it consists of 6.25 into 10 to the power 18 numbers of electrons. So the 1 coulomb of charge is quite very large unit. It is a very large unit or large amount of charge. So in order to, but we practically we cannot handle such a huge amount of charge. So that is, or it is, we deal with smaller fractions of charges. So the smaller units of charges are, or the smaller amount of charges are microcoulomb, then nanocoulomb. As we know, 1 microcoulomb is equal to 10 to the power minus 6 coulomb, and 1 nanocoulomb in 10 to the power minus 9 coulomb. So these are the smaller units or smaller fractions of charges which we generally take into account while dealing with charges, or for practical purposes we deal with the microcoulomb and the nanocoulomb. So from this discussion we concluded that there are two kinds of charges in nature, and the charges, they can only be developed in a body by the transfer of electrons. But how the electrons can be transferred, or in the previous class as we have discussed that a body can only be charged by transferring electrons. You cannot take out the protons of the body out of the body. That is why the only way to charge a body is by transferring the electrons, either by giving electrons to the body or by taking out electrons from the body. But in which way we can do it? So we will discuss it now. So let us now discuss about the methods of charging a body. You see, the methods of charging, that means the methods in which we can transfer electrons from one body to another. So there are basically three methods of charging a body. One is your charging by friction, then charging by conduction, and lastly charging by induction. So going into the details of the first method, that is the charging by friction. You see, when a glass rod is rubbed with silk, after rubbing, when a glass rod is rubbed with silk, after rubbing the glass rod with the silk, the glass rod develops positive charges. This was established from the behavior. That means the way the glass rod behaves, so it was assigned positive charge. So the glass rod was developed a positive charge, and the silk, it developed a negative charge. So how the bodies develop these charges due to rubbing with each other or by virtue of friction? So the charging by friction, it is the method of charging where one body is rubbed on the surface of another, or one body by virtue of friction it develops certain charges. So you see, when a body, the basic fundamental of charging by friction is that, as we have already discussed in the previous lecture, that when the outermost orbit electron, they receive energy, they become free from the atom, or they jump out of the atom. So when a body is rubbed with, suppose a glass rod is rubbed with silk, what happens? During rubbing, the friction is there. So definitely we have to do certain work against the force of friction. So that work is stored as the potential energy in the surface. Or you can say, while rubbing, there is some production of heat, and heat is a form of energy. So due to that energy will be utilized in driving electrons from the surface of the materials. That means when a glass rod will be rubbed on the silk cloth, the glass rod will gain sufficient, the outermost orbit electrons present in the glass rod, these electrons, they will get sufficient energy in order to jump from the glass rod to the silk. By virtue of which, or by doing that, the glass rod will acquire a positive charge, whereas the silk cloth will acquire a negative charge. You think the same thing happens in case of when an ebonite rod is rubbed with wool. The ebonite rod becomes negatively charged, whereas the woolen cloth becomes positively charged. But you see, the wool and the silk are the same kind of material, that means they were clothes, whereas the ebonite and the glass rod, they were also similar kind of solid materials. But when the glass rod is rubbed with silk, the electrons are transferred from the glass rod to the silk cloth, making the glass rod positive and the silk cloth negative. But in this case, when the ebonite rod is rubbed with wool, the electrons are transferred from the wool to the ebonite rod, making the woolen cloth positive and the ebonite rod negative. You think why these type of things happen? In one case, the electrons are transferring from glass rod to silk. In another case, the electrons are transferring from the wool to the ebonite rod. So the transfer, is there any factor on which the transfer of electrons will depend? Yes. The factor on which the transfer of electrons will depend is called as the work function. That means the work function of the substances will determine the electrons will be transferred from where to where. So you see, when the glass rod is rubbed with silk, the electrons are getting transferred from the glass rod to the silk, making the glass rod positive and the silk cloth negative. So from this, it is concluded that the glass rod is having lower work function and the silk cloth is having higher work function. If you go into the definition of the work function, it states that it is the amount of energy required to release an electron from the surface of a material. So from this definition, It is the amount of energy required to release an electron from the surface of a material. So you see, the glass rod when rubbed with silk, definitely if the substance which is having lower work function, so definitely lower amount of energy will be required to release an electron from that substance. And the substance which receive electron, definitely it must be having higher work function. That is why it will require much more energy in order to liberate electron. So when the pairs are rubbed with each other, the substance which is having lower work function out of those pairs will definitely lose energy, and the substance which is having higher work it will lose electron, and the substance which is having higher work function, it cannot lose electron, instead it will receive the electrons. So the substance which is having lower work function, it will lose electron and it will be positively charged. So the substance having lower work function, it will be positively charged because it will lose electrons easily, and the substance which is having higher work function, it cannot lose the electron, instead it will receive the electron and it will be negatively charged. So when the ebonite rod is rubbed with wool, so the work function of the ebonite rod is higher than that of the wool. That is why the wool easily loses electron and the ebonite rod receives it. Thereby the wool becomes positively charged, whereas the ebonite rod becomes negatively charged. So the substances which will lose electron and which will receive electron out of the rubbed pairs, it will depend upon the factor work function. So this is the basic of the charging by friction. Now you see, during friction the required characteristics are, in order to develop frictional electricity, the frictional electricity is also called as the static electricity because it is static in nature. The charges, they don't move, they originate locally. You see, when glass rod is rubbed with silk, then whatever the charges develop, the charges are static in nature. That means they do not move. So that is why this type of electricity is also called as the static electricity. The same thing happens in case of silk cloth as well. So the basic criteria for charging by friction is that both the bodies initially they are chargeless. That means they are neutral bodies. And the second criteria is they must be rubbed with each other. And the third thing is the charges are static in nature. After development, the charges are static in nature, they do not move. And one thing you see, metals, they cannot develop, they cannot be charged by friction, or they cannot develop static electricity. Now this question is quite frequently asked to the students, that why metals cannot develop static electricity. You see, as the metals are good conductors of electricity, so when it will be rubbed on a suitable substance, although it may develop additional charges, but those charges will not kept fixed at their position, as the metals are good conductor of electricity. So the charges which will develop, they will spread throughout the body of the metal, or they will flow throughout the body of the metal, and eventually when you are holding the charge and you are touching the ground, so as the metal is a good conductor, so by conduction or by the flow, as it is a good conductor, it will flow throughout the metal, then through the body it will move to the earth. So the static electricity or the frictional electricity, due to this fact, it cannot be developed in the metal. So from this we saw that when one body is rubbed on the surface of another, the body which is having lower work function, it loses electrons and it becomes positively charged, whereas the body which is having higher work function, it gains electron and becomes negatively charged. So there is a series called as the triboelectric series, and it is arranged, the triboelectric series is arranged as per the order of the work function. The substances which are higher in the order, higher in the table, will be positively charged. So, and the substances which are lower in the table, they will be negatively charged. Now you see, during the development of frictional electricity, that means when frictional electricity develops, so one body, the body which loses electrons, it becomes positive, and the body which receives electrons, it becomes negative. Body which receives electrons, it becomes negative. Now you see, the charge lost by this body, that means the number of charges that will be lost by this body will be equal to or equal into pair. That means the charges will be produced in pairs. That means if it will develop, it will lose 5 electrons and it will develop plus 5 charges, that plus 5 unit charges. So the another body will also develop minus 5 units of charges. That means the charges will be lost and gained in pairs, so that the charge lost will be equal to charge gained. Now another thing is that when during charging, what will happen? There will be transfer of electrons from one body to another. So the body which lose electron will become positively charged, and the body which gain electron will become negatively charged. So one question arises, is there any transfer of mass during charging? Transfer of mass while charging. You see, charging refers to the transfer of electrons, as we have already discussed. So during the transfer of electrons from one body to another, as we are discussing in your ebonite rod or wool, ebonite rod, when it is rubbed with wool, so the electrons they transfer from wool to the ebonite rod, and the wool becomes positively charged, whereas the ebonite rod becomes negatively charged. So during this phenomenon, is there any transfer of mass? Yes, you see, the two fundamental particles, that is the protons and the electrons. So let us discuss about the electrons. You see, the electrons are the particles which are transferred during charging. So the electrons, it has a charge of minus 1.6 into 10 to the power minus 19 coulomb. So the magnitude is 1.6 into 10 to the power minus 19, whereas it has a negative charge. So the charge of the electron is minus 1.6 into 10 to the power minus 19 coulomb, and the mass of the electron is 9.1 into 10 to the power minus 31 kg. You see, during charging, as we are saying, there is transfer of electrons from one body to another. So definitely, as the electron is having a mass of 9.1 into 10 to the power minus 31 kg, so the body which either loses electron or gains electron, it also loses mass and gains mass. So the body which will lose electron, or let us take for example, suppose a body will lose one electron, then it will lose a mass of 9.1 into 10 to the power minus 31 kg. And the body which will receive electron, it will also receive the 9.1 into 10 to the power minus 31 kg mass. So a positively charged body, as it loses electron, a body after losing electrons, it will be positive. So a positively charged body, as it loses electrons, it loses mass, and as a negatively charged body, it gains electron, so it gains mass. So for like bodies, after charging, then there will be transfer of electrons. So after charging, their masses will be different. And the positive charged body, as it will lose mass, it will weigh less, that means it will have a lesser charge, lesser mass, and the negatively charged body, as it gains electrons and gains mass, it will have a higher mass. So let us move to the next method of charging, that is charging by conduction. So for conduction, previously in friction we saw that both the bodies are brought in contact, they are rubbed on the surface of one another, and electrons are transferred from one body to another, and one body becomes positively charged while the other body becomes negatively charged. So both the bodies were initially neutral, but in conduction, you see, let me write the definition first. It is the method of charging, where charges flow from a body at higher charge to a body at lower charge when they are brought in contact. So long as the bodies acquire equal amount of charge. You see, in conduction, so it is a method of charging where charges flow from a body at higher charge. So one body must be at higher charge to a body at lower charge. The other body must be at lower charge. That means one body must be charged, the other body may be charged, and if charged, the charge must be less than the charge of the other body, or it may be the higher than the charge of the other body. So there must be a difference of charge between the bodies. So there must be a difference of charge and they must be brought in contact with each other. So when they will be brought in contact, charges will flow from a body at higher charge to a body at lower charge, so long as both the bodies acquire equal amount of charge. So the necessary criteria for conduction, that first of all, one body must be charged and the other body may be charged and may be neutral. The second condition is there must be a difference of charge in between the bodies, and the third condition is they must be brought in contact, and after charging both the bodies acquire equal amount of charge. So you see, if you consider two bodies A and B, if one body is having a 5 coulomb of charge and one body is neutral, if they are brought in contact and they are separated, so after charging what will happen? During contact, charges will flow from body having 5 coulomb charge to the neutral body, so long as and when they are separated, each body will have a charge of 2.5 coulomb and 2.5 coulomb, because charges will flow so long as the bodies acquire equal amount of charge. So another example, let us take a body A is having 3 coulomb of charge, another body B, it is having 7 coulomb of charge. Then when they are brought in contact, both the bodies, now there will be exchange of charge and charges will flow from body at higher charge to a body at lower charge, and when they are brought in contact and separated, after separation each body will now have 3 coulomb plus 7 coulomb, that is 10 coulomb by 2. So each body will now have a 5 coulomb charge and a 5 coulomb charge. So this is the method of charging by conduction, where one body must be charged and the other body may be charged and may be neutral, and the charges, the already existing charges, they flow so long as both the body acquire equal amount of charge. So this was the method of charging by conduction, and the last method is charging by induction. So let us move to charging by induction. You see, In by charging by friction and charging by conduction, the bodies were actually in contact. But in this method of charging, here the bodies will not brought in contact actually. So first let me write the definition. So it is the method of charging. It is the method of charging where one body, where charges develop on a body when another charged body is brought near it. But they don't come in contact. So in this method of charging, charges develop on one body by bringing another charged body. Remember, in conduction there were at least one charged body. In friction, both the bodies were neutral, and in induction, one body must be charged, one body, and the other body may be charged or may be neutral. But it is different from the conduction in the way that in conduction there was actual physical contact between the bodies, whereas in induction the bodies will not come in contact actually. So let us take the example. Suppose when a body A, it is positively charged, so one body must be charged already. When it is brought near a neutral body B, what will happen? As we know that like charges repel and unlike charges attract, so the positive charges will now repel the positive charge inside, they're already inside the body B to this side. So due to the phenomenon of repulsion, the positive charges will come to this side, and by virtue of attraction the negative charges will come to this side. You see, but there is no development of additional charges. The only charges which are already inside the body B, they are only getting rearranged. The positive charges will repel the positive charges, so they will come to this end, and the negative charges will be attracted, so they will be arranged to this end. So by virtue of which the charges will only reorganize themselves. So there is no extra charge developed on the body. But as the negative charges are closer to the positively charged body and the positive charges are away from the positive charged body, so the body B, this end will feel a more attractive force in comparison to the repulsive force between the positive charged body and this end of positive charges. So due to the attraction between the end of this negatively charged negative charges and the positively charged body, this body will attract this body. So if we will ground this body, if we will connect this side of the body to the ground, what will happen? That these positive charges now, as they are repelled by the positively charged body, this side of the positive charges, they will flow to the ground. Once they are connected to, this body is connected to the ground with a wire, these charges will flow through the ground. And if we will cut the connection, and the negative charges will not go with that positive along with the positive charges, because the negative charges are held by the force of attraction by the positively charged body. So due to, as the positive charges will flow to the ground, if we will now cut the connection, then the body will be develop or net negative charge. So in this method, we charge the body B by bringing another charged body A near it, but we are not bringing them in actual contact. So this method of charging does not require actual contact, so it is from a distance. So if Q amount of charges develop in the Q dash amount of charges develop in the body B by bringing Q amount of charge in the body A, then the amount of charge Q dash produced is given by Q dash is equal to Q minus Q by K. We'll know the K later on, but for this moment you only know that the q dash charge developed in the body B will be equal to q minus q by k. So q dash is equal to q into 1 minus 1 by k. So this is the formula for the charge developed by induction. You see, so during the process of induction, there is no net charge developed so long as the body is not connected to, or this side of the body is not connected to the ground. So there is no development of extra charge. So during induction, still the charge of the body is zero, net charge of the body is zero. There is no development of additional charge, only the charges rearrange themselves, so still the net charge of the body is zero. But once the body will be connected to the ground, then only this side of the charges will flow, but this side of the charges, as they are held together by the positive charge, they will not flow, leaving behind the negative charge, net negative charge on the body B. So this is the method of induction by which the body can be charged.